Hey guys, in this video we're going to be starting our review for your math exam. So if you remember, there's three topics that you're going to be tested on. The first one being linear functions, so lines. The second one being quadratic functions, or parabolas. And the third one being trigonometry. Okay, so we've already been through a bit of a breakdown on the things you'll need to know. So for linear functions, you will need to know how to find the equation of a line given a graph and how to turn the equation of a line into a graph, so how to make a graph based on the equation. Alright, so what we're going to start with in this video is just a review of linear functions, and we'll come to the other ones in subsequent videos. So we'll start with a review of the equation of a line. Now hopefully you remember this. If you don't, it should be in your notes. Equation of a line. Now hopefully you remember that the equation of a line is given as y equals mx plus b. Okay, so this might seem like, whoa, we did this a really long time ago. But so this is the equation of a line, and let's just remind ourselves of how it works. So the m value we call the slope of the line, and the b value is called the y-intercept. Y-intercept. Hopefully you can see that all right. So the m value is called the slope and the b value is called the y-intercept, and we'll talk a little bit later on how to find those. Now in the equation of a line, y is not going to be replaced by a number and x is not going to be replaced by a number. These are our variables. X is our independent variable, that is you choose it, and y is our dependent variable, that is you get it based on what you chose for x. Don't worry about those names. I'm not going to test you on those names, probably. As long as I don't forget that I said I wasn't going to test you on it, then I won't test you on it. M and B are constants. These are two letters that we use in this equation of a line. This is the general form of the equation of a line, but we will replace m and b with numbers in an actual question. So your question might read something like y equals 4x plus 3. So you'll notice that the y is still there and the x is still there, but m and b have been replaced by numbers. Alright, so what are m and b? What is the slope of a line? So let's remind ourselves of that. So let's see, you've got some line and it intersects with the point 2, 5, and it intersects with the point, let's say 6, I don't know, 11, something like that. Alright, so just a reminder, because trigonometry doesn't involve a lot of graphing the way quadratics did, remember that when you're writing out the coordinates of a point, you write the x-coordinate first and then the y-coordinate. If you have trouble remembering that, just remember that one is going to be x, one is going to be y, and they just go in alphabetical order. X comes before y, so the x-coordinate goes first. So you have these 2 points, and the slope of the line, I'll just write out the equation and then we'll break it down. So the slope of a line is delta y over delta x. So if you remember, the delta sign means a change in, a difference in. Alright, so it's a change in y divided by a change in x. Now remember, y is in that direction and x is in this direction. So our change in y, our vertical shift, that if you were in an elevator, how many floors up or down do you need to go? and also are you going up or are you going down from left to right. And then your change in x is your horizontal displacement, that once you get out of the elevator, how far do you have to walk horizontally on that floor, for example. Okay, so the change in y is just going to be the difference in height of this point and the height of that point. So we've got, you know, this one is at a height of, we've got our y coordinate here is 5 for the first one, and our y coordinate for the second one is 11. So that means that this dashed line is at a height of 11 units above the x-axis, and this dashed line down here is 5 units above the x-axis. Alright, so the x-axis would be like down here or something like that. That would be the positive x-axis, would be somewhere over there. Okay? Yeah, okay, something like that. Roughly, not exactly, but close to that. So the change in y, let's say this was our point number 1, I'll call it P for point, P1, and then this one over here will be P2. So going from left to right, well, you don't have to think of it as left to right. So P2 has got the coordinates x2, y2, because it's point number 2, and this one has the coordinates x1, y1. So some people will think of this in different ways. Some people will look at it and think, okay, left to right, or you know, how many, you know, am I going up or am I going down as I go from left to right? You don't have to worry about it that way. What I'm going to do is I'm going to explain it in a way that you can use this formula to figure out your slope. So remember that a change in something, if you've got a change in temperature, for instance, then you're going to start with, if I say the change in temperature from this morning to this afternoon was 8 degrees, then when I'm calculating the change in temperature, I'm going to start with the final temperature, the temperature right now, and I'm going to subtract from it the temperature this morning. So, for example, if it was 6 degrees in the morning, I'm using my temperatures now, not yours. If it was 6 degrees in the morning and 14 degrees in the afternoon, then the change in temperature is, well, whatever the difference between 6 and 14 is. So in this case, the change in temperature was 8 degrees. But is it positive 8 or negative 8? If you're doing the math too quickly, it's easy to make a mistake and say negative 8, but it's very obvious that the change is positive 8 degrees because, well, it was 6 degrees this morning, so it must be 8 degrees warmer now in the afternoon. If the change was negative 8, that means it would be 8 degrees colder in the afternoon, which is not the case because it's 14 degrees. So basically what that tells us is when we're doing the math to figure out the difference between these two, we start with the second number, the final number, and then we subtract the first number from it. So if you remember from our equation, I'm going to rewrite this equation. Instead of writing delta y, you can instead say y2 minus y1. Alright, and you can do the same thing down here at the bottom. You can do x2 minus x1. So now all you have to do is make sure that you've labeled these points, x1, y1, and x2, y2, and it actually doesn't matter which one you call point 1 and which one you call point 2. All that'll happen is you'll either have no negative signs or a couple of extra negative signs that cancel out with each other. But basically, as long as both the x and y coordinate of the same point have this same subscript at the bottom, so basically as long as the y coordinate that's attached to this x1, they both have the same subscript. So x2 is paired with y2 and x1 is paired with y1, your answer will be correct as long as you follow this formula. So basically what you do is you take the y coordinate of the second point. So, well, let's do that. If I just make some space down here, because we don't need the x-axis in this diagram. So y2 is, well, we've got the second point because it's y number 2. So point 2, the y coordinate is 11, So we take 11 minus y1, the y coordinate of the first point. So that's here's the first point, the y coordinate is 5, and that is our change in y. So basically what that is that if you have these two dotted lines, this difference right here is delta y, or y2 minus y1. This is the vertical change, that if you were on the 5th floor of the building and now you're on the 11th floor of the building, how many floors did you go up or down? Okay, so we'll end up calculating this in the next step. It's a very easy calculation. But then before we get to that, we'll do the denominator, the x bit. So x2, so we go over to point 2, we find the x coordinate, that's 6, minus x1. We go to point 1 because it's x number 1, and then we take the x coordinate, which is 2, and we plug that in right there. Now we solve that. 11 minus 5 is 6, 6 minus 2 is 4, and that's your slope, which you can simplify to 3 over 2. Now what does this 3 over 2 mean? This 3 over 2, the other way you can sort of think of it is you can think of it as, I'm going to have to remove this 2, 5 now. You can think of this as rise over run. That is, if you're going up 3 units, for every 3 units you go up, you have to go 2 units over. 3 units up, 2 units over. And you just keep doing that. So from here, you just go up 1, 2, 3, and then over, and then up 1, 2, 3, and then over. So that's how you can use your slope to graph something like this. So if you didn't have the line but you had the slope, then all you would need is a point to start with. But I'm getting a little bit ahead of myself. So basically your slope you can get from this by following this equation. Now for the y-intercept, I'll stick to, so we've got the slope now if you were given a graph, so now we'll do the y-intercept if you were given a graph. So if you're given a graph, something like this, you've got your positive x-axis over there, positive y up there, and you've got like 1, 2, 3, 4, 5, something like this. 1, 2, 3, 4, 5. Your y-intercept, that is the b value, y equals mx plus b. This b value, your y-intercept, is just where the line crosses this y-axis. So if you look at this one that I've drawn, on your exam, whatever line I give you, the y-intercept should, unless I've made a horrible mistake, the y-intercept should be some easy, nice round number. It'll be something like 3 or 1. It won't be like 7/12 or something weird. It'll be like 1 or 5, 10, something like that. The hardest I might make it is, 1.5. I might make it a half a unit that you could have your intercept at, but otherwise it'll be at some whole number, probably, just to keep things simple. So you can just look at this graph and see, well, if you got closer to it, or if I drew this bigger and better, then you'd very clearly be able to see that this line intersects right where I've drawn the line for 3 units up. So in other words, at the point where the y value is 3, the x value is 0. That is, it's on the axis. If it's on the y-axis, it hasn't moved left or right. So that means its x coordinate is 0, right? This is the 0 mark for x, and then you start counting that way. So this is your 0 mark for x. You don't move left or right. You move straight up 3 units, and you found a point that's on the line and on the y-axis. So this is your y-intercept, just where the line crosses the y-axis. All right, so you can, if I've given you a graph, all you have to do is look at it and figure out where it crosses the line. So when your equation is y equals mx plus b, m is the harder one to figure out. B, you look at this, oh, it's 3, so instead of plus b, I put plus 3. If it was intersecting down here at, let's say, negative 3, for example, all right, let's say it's intersecting down here at negative 3, then instead of having plus b, you'd have y equals whatever your slope is, mx plus negative 3. But you don't need to write plus negative 3. You might as well just write minus 3. So this bit right here takes the place of b in your equation. So that would be your y-intercept right there, and you would have figured out your slope using the technique that we were talking about before. In the second half of this video, I will talk about the reverse of this. So you're given an equation, and now it's your responsibility to draw the graph, which can be harder because this one, you just have to look at it and, do a little bit of counting, and then you're done. This is all basically just counting. With the other, the other way around, it is a little bit more work. So in part 2, we will start with reviewing that.